In our last video, we talked about the trigonometric identity. What we are going to do, we are going to continue the same discussion and talk about some more trigonometric identities. So what I'm going to do, I'm going to use this triangle from the last video. So as you can see, I have a triangle ABC where A is the reference angle. So this is my reference angle, and what I'm going to do, I'm going to consider this triangle. So as you can see, the name of the side opposite to A is A, opposite to vertex B is B, and opposite to vertex C is C. And as you can see, if A is the reference angle, then A will be my opposite, small b will be my adjacent, and small c will be my hypotenuse. So as you can see, sine is opposite over hypotenuse. So as you can see, A is my opposite and C is my hypotenuse. Or I can also say BC is my opposite and AB is my hypotenuse. So I got my sine A. In the same way, I got my cosine and tangent. Now what I'm going to do, I'm going to write few more other trigonometric ratios. So the next one that I'm going to write is cosecant. So we all know that cosecant is reciprocal of sine. So if sine is BC over AB, then cosecant will be AB over BC. So this is my trigonometric ratio for cosecant. In the same way, for cosine, I can write the reciprocal of cosine as secant A, and secant will be AB over AC, because secant and cosine, they are reciprocal of each other. And the reciprocal of tan is cotangent. So since it's a reciprocal, I can write as cotangent is equal to AC over BC. And this is my cotangent. Now let's consider the Pythagorean theorem. So I'm going to consider the Pythagorean theorem. And if you remember, the Pythagorean theorem was a squared plus b squared is equal to c squared, and my a is bc, so I will write bc squared plus small b is ac squared, that is equal to small c is ab, so I will write ab squared. Now what I'm going to do, now I'm going to divide one of these ones. So what I'm going to do, I'm going to divide both sides by bc squared. So I'm going to divide both sides by bc squared, and if I do that, I will get bc squared over bc squared plus ac squared over bc squared is equal to ab squared over bc squared. Now as you can see, bc squared can cancel out by bc squared, and I get 1 for this thing. So I have 1 plus, I can write AC over BC as AC over BC whole squared, that is equal to AB over BC whole squared. Now let's look at these trigonometric ratios and see which one matches the first ratio, which is right here. So I'm going to write this one as 1 plus, let's see which trigonometric ratio is AC over BC. So as you can see, cotangent is AC over BC. So I'm going to write cotangent for this trigonometric ratio. So I'll write inside the bracket cotangent A squared is equal to, let's see which one is belonging to AB over BC. So as you can see, AB over BC is cosecant. So I will write that is equal to, inside the bracket, cosecant A whole square. Now, I'm going to simplify further, and if I do that, I have 1 plus cotangent square A is equal to cosecant square A. And this is my second trigonometric ratio. So for next trigonometric identity, what I'm going to do, I'm going to consider this term right here. So I will write BC squared plus AC squared is equal to AB squared. Now, this time I'm going to divide both sides by AC squared. So I'm dividing both sides by AC squared. So the first term is BC squared over AC squared. If I simplify, I can write that one as BC over AC whole squared plus the second term has both numerator and denominator the same. So I can cancel out numerator and denominator and I will left with 1 is equal to, I simplify this one and I can write as AB over AC whole square. Now what I'm going to do, I'm going to look at these 6 trigonometric ratio to see which one belongs to the first ratio. So the first ratio is BC over AC, and if I look closely, BC over AC is my tangent. So for the first trigonometric ratio, I'm going to write tangent of A whole square plus 1 is equal to, now let's see which one is this ratio. So if I look closely, I can see secant is the one because secant is AB over AC, and that's what I'm looking over there. So for AB over AC, I can write secant A. So I will write inside the bracket secant A whole square. If I simplify further, I can write tangent square A plus 1 is equal to secant square A. And this is my third trigonometric ratio. So in this video, we have talked about 2 trigonometric ratios. The very first one is this one, which is basically 1 plus cotangent square is cosecant square. And the second one is 1 plus tangent square is equal to secant square. And this is how we'll find the trigonometric identities for trigonometric ratios.